Hello guys, and welcome to this video. So in this video we'll be looking at the November 2024 final exam question. Yeah, and this one is question 2, which has to do with one of, or rather let me just say, Newton's laws. So let's get into it. It reads as follows. It says, in an experiment, a crate of mass 8.5 kg lying stationary on a rough horizontal table is connected to a mass hanger by means of a lighting extensible string passing over a frictionless pulley as shown in the diagram below. Mass pieces are added to the mass hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different masses to increase the hanging mass each time. Then they say ignore the effects of air friction. And we can see here, guys, that this is our crate and it's stationary. And then on the other side of our table, since our crate is on the table, is our mass hanger there. And we know that here, guys, on this string is where we will find our tension. Okay, so if we just look at this diagram and look at the forces that may happen to be here, we'll say that on the crate we actually have two forces. The first force is the tension force, which is the force that is on the string, and then we will also have the force of friction, and that friction in this case will be static friction. Then when we look at this mass hanger, we will have two forces as well here. The first force again here will be the tension that's on the string, and then the second force that we'll have is the force of gravity, or you could say the weight, and we know that this is equal to mass times gravitational acceleration. So that's just us looking at the type of free body diagrams that we might produce out of this without looking at the question yet. Okay, so on the crate we have two forces, and on the mass hanger we also have two forces. The common force here is what? Is the tension, okay, on both of these two objects. Now let's check what's going on the next section. They say that the results obtained were used to draw the sketch, the graph below, or rather, yeah, they were used to draw the sketch graph below. And this is our graph, and we can see that on our graph we happen to have the masses of the mass hanger, two masses there. Then we have our acceleration. Okay, but we'll talk about that after looking at the questions. Let's check what the questions want. The first one, guys, says we have to define the term static friction. Okay, and for us to define this, or rather for us to give this definition, we have to remember what static is. It means that an object is stationary. Okay, and friction obviously talks about the opposition of the motion of an object, basically, right? So static friction will have to do with what? With our friction working on a stationary object, meaning that our friction here doesn't want the object to actually move. And we will get that definition from our exam guideline. Let me just check. So guys, this is the definition of static friction. As you can see, it says that static frictional force is the force that opposes the tendency of motion of a what? Stationary object, okay, relative to a surface. Like I said, static will have to do with a stationary object, and yeah, the force of friction opposes the tendency of motion of that object. Okay, so that is the definition: the force that opposes the tendency of a motion, or rather the tendency of motion of a stationary object relative to a surface. That is the definition. Now we move on to the next question. Okay, the next question, guys, says draw a labeled free body diagram showing all the horizontal forces acting on the crate just before it starts moving. Okay, so we are going to have to look at the bold widths here, horizontal and just before. Okay, so those are the ones that are going to help us know how to draw our free body diagram. Now let's remember, before we went into our questions, we already said that on our crate we are going to have two forces, right? And those forces will be the force of static friction and also the tension. Okay, or rather, yeah, which is the tension on the string, let me say. And we can also see that our marks here, guys, is 2 marks basically for this question. And we know that the number of marks talks about the number of what? The number of forces that have to be on our free body diagram. So when we draw our free body diagram, this is how we'll have it. Firstly, we obviously draw a dot like that. Then the second thing that we're going to look at, guys, is this part here. The horizontal forces obviously are found here. Okay, those are the horizontal forces, the ones that are acting on this block when it's on top of the table there. And then the just before part talks about what will be the magnitude of these forces, and we don't really know the actual size, but what we know is that our forces which will be on this block will be equal. And we already know that the first force is going to be tension, and the second force is going to be the force of static friction. Okay, obviously, guys, I'm not using a ruler, so my drawing won't be as perfect, but what I want you to know is that our two forces here are expected to be equal. Okay, the tension force will be equal to the static frictional force. Okay, I hope you understand that. The reason why these forces have to be equal is because if they are equal, then our object will remain in its position of rest. It will not go anywhere because the forces are balanced. Remember, for an object to move, we have to have what? An unbalanced force, or a force that is, how do I put this? An unbalanced force, or a force that is not equal to zero. Yes, that's what I wanted to say. So in this case, because the forces are equal and moving in opposite directions, that means that they are balanced, and because of that, our object will not go either to the left or to the right. It will just remain stationary. Okay, so that's how you draw your free body diagram there. Now let's go to the next question. All right, the next question, guys, says we have to calculate the coefficient of static friction. Okay, so for us to do that, we have to start by looking at the formula for static friction, and it's going to be Fs max is equal to static coefficient of static friction multiplied by the normal force. Okay, but before we go to this formula, because this formula is just for us to know that what we want is there on this formula. This is what we want. Okay, but before we go there, guys, let's look at our free body diagram. Remember, when we are doing our forces, normally when we are calculating a certain force, whatever, we say F net is equal to MA, right? That's what we normally say. But in this case, guys, we want our F net to be equal to 0. Why are we having our F net being equal to 0? It's because our object, which is the crate, is stationary, the same as that mass hanger. The objects are stationary, and if they are stationary, it means that we have zero acceleration, and zero acceleration will mean that we will have everything being 0 here. So we will have F net is equal to what, in this case, 0. And how many forces we have on our crate? Excuse me. We already said that on our crate we happen to have 2 forces, right? Which is what? The force of static friction plus the force of kinetic friction, but they are moving in opposite directions. Okay, so let me just put it this way. Let's say our direction to the right, this one will be positive since it's moving to the right, and this one will be negative since it's moving to the left. So that means here we will have T minus Fs is equal to 0. And if you check, guys, when I transpose Fs to the other side, and apart from me saying that, our forces are going to be equal. The tension force will be equal to the static friction force, and we already said that here when we drew our free body diagram. Okay, so that means I'm gonna have T being equal to Fs. So the tension is equal to the static frictional force. Does that make sense? But this won't be enough for us to get our answer. For us to get our answer, we will also have to look at our mass hanger. And if I draw the free body diagram of the mass hanger, and remember, here we are still saying that our object is stationary, or rather both these objects are stationary. So if I'm drawing the free body diagram of the mesh hanger, this is what I will have. Firstly, I will have my tension, and then this side I will have my force of gravity or weight, right? And we know that weight is equal to, okay, I already said it there, that weight is equal to mass times gravitational acceleration. Now, what does this mean? This means that my tension, guys, since the objects are stationary, even this one here, the mesh hanger, is stationary, and that means the tension force will actually be equal to the force of gravity. I hope, guys, that makes sense, okay? Because these forces are balanced, and if that's the case, it means then that my tension force, since it's equal to the static friction, will be equal to this, guys, okay? It will be equal to the mass times gravitational acceleration, okay? So that's what I'm gonna have there. Now I'm answering this question. So I'm starting here. Let me just write this. So this is 2.3.1. That's my first part there. I'm saying that T is equal to Fs, and then I'm also now saying that T is equal to mg. And since we know that tension, guys, is the same for both these objects, they will have the same tension. That means that I can take this mg and put it here on this equation. I hope it makes sense. So that's what I'm going to do next. Okay, I'm just going to write that here. I hope you are moving with me. We are moving from here to here, and now we are saying that since tension is equal to mg, then that means where I see T on this formula, I'm going to put mg is equal to this Fs. But remember, Fs is actually equal to this. Okay, Fs is equal to that, which is what? The coefficient of static friction multiplied by the normal force. I hope, guys, you are following so far. Then when we proceed, because we have to now substitute, the mg here, guys, has to do with what? This one has to do with the mesh hanger. So I'm just gonna, let me erase there. So T is equal to mg, guys, or T is equal to fg, has to do with the mesh hanger, right? It has to do with the mesh hanger. And then this one here has to do with what? The crate. Or let me just write it here. This one has to do with the crate. I hope you are following. So it means that where I'm seeing mg, I'm supposed to put the mass of what? Of the mesh hanger. But I'm doing this when the mesh hanger is stationary. And when the mesh hanger is stationary, guys, it has this mass, because our acceleration there is supposed to be 0. Okay, so if our acceleration is 0, it means that the mesh hanger, when not moving, has a mass of what? 4,2 kg. So that's what I'm going to put here. I'm going to say 4,2 multiplied by 9,8, which is constant, is equal to, this one is what I'm looking for, so I'm just gonna write S there. Normal force, guys. Normal force obviously has to do with this object. First of all, the normal force we are looking at here has to do with this crate, and we can see that the crate is having a mass of 8,5. Remember that normal force as well is equal to what? Mg, or rather, let's start it here, that normal force is equal to Fg, which is equal to mg. So where I see normal force, it means I'm substituting the mass of the crate, okay, the mass of the crate, and it makes sense because normal force has to be perpendicular to the surface, right? So our crate, since it's on top of this table, will be perpendicular to what? It will mean that the normal force of the object will be perpendicular to the surface. So the mass of our crate is 8,5, and we'll multiply by 9,8. Then from here, guys, we will divide by 8,5 times 9,8 on both sides. Why? Because we are solving for this. Okay, so we will have 8,5 on both sides, dividing this, the two sides rather. Yeah, and we know that this side, everything is gonna cancel. Therefore, my coefficient of static friction will be equal to, this one I'll put on a calculator as it is. So what I will say is 4,2 multiplied by 9,8 divided by 8,5 multiplied by 9,8. Okay, my math is not mathing here. I have to put this stuff inside the brackets. So I'm just gonna say 4,2 in brackets multiplied by 9,8 divided by 8,5 in brackets, 8,5 multiplied by 9,8, all of that will be in brackets, and the value I get, guys, is going to be 0,49. okay, remember the coefficient of static friction will not have a unit. Okay, let's just go back to what I did. Firstly, I said that we will look at the forces acting on the crate, and its two forces, which is tension and the static friction. And since these forces are balanced, it means they are equal. Thus T is equal to Fs. And then we go to find the forces that are acting on the mesh hanger, and those forces are supposed to be T minus or rather, yeah, it's T, which will be equal to what? To mg. Again, that's because these two forces are also equal, or you can write T minus mg is equal to 0, and when you transpose that, this is what you will have. Then from there, because tension is common for both of these two, where we see T on this equation, we will put mg, which we do there, and where we see Fs, we substitute this, which is there. Then from there, on this side, we know that this mg belongs to what? To the mesh hanger, so we substitute by the mass of our mesh hanger there and the 9,8, and then this side we use the mass of what? Of the crate, and then yeah, the rest is history, guys. Do your math and then find your answer. I hope it makes sense. Let's move on to the next question. All right, guys, so the next question says we have to calculate the magnitude of the acceleration represented by y on the graph if the coefficient of kinetic friction between the crate and the table is 0,40. okay, this is worth 5 marks. So this is how we'll answer this question, guys. First of all, it's important to continue looking at the free body diagram of our two objects, or rather, yeah, the free body diagrams. So now we have a different situation, because they are talking of the coefficient of kinetic friction, and they are saying we have to find the acceleration. This means that now our objects are actually in motion. The objects are moving. Okay, and if you look at the definition of kinetic friction, let me just go to my exam guideline. This is it here, the definition of kinetic friction. Let me just highlight it. They say that it is what? It is the force that opposes the motion of a moving object relative to what? To the surface, basically, or to a surface. All right, that is the definition of kinetic friction. So that means our object now, guys, is in motion. And if that's the case, it means if I'm drawing the free body diagram of the crate, I will say the crate still has tension, but now the force of friction it has is that of kinetic friction. So this will be my new free body diagram. Okay, and then I'm also gonna look at the free body diagram of my hanger. So this one is the crate, and I'm using this information because it's going to help me, guys. So this one is the hanger, which is Fg, or you could do W, and we know that this is equal to mg. Then we will also have tension, right? Then for 2.3.2, now we are going to use the free body diagrams to come up with our equations. We'll start by looking at the crate. If we look at the crate, guys, and we formulate our formula, we obviously have to start by saying F net is equal to MA. Here F net cannot be equal to 0 because our object is moving now, guys. Okay, and it's not even moving at constant velocity, nor is it stationary. If it's moving at constant velocity, A is 0. If it's stationary, then A would still be 0. But now remember, we are looking for this A. So when we proceed with this question, we will look at the forces that are on the crate, and we'll say that this one, since our object will be moving to the right, in this case we'll say that our tension there is positive. That's what we're assuming, guys. I don't know if it's moving to, but it should. So our tension will be positive and our kinetic friction will be negative. Okay, our kinetic friction will be negative Fk. Okay, all of this will be equal to Ma. But let's remember again, what is kinetic friction in terms of its formula? Fk is equal to what? The coefficient of kinetic friction multiplied by the normal force, right? That is Fk, all of this. And this, if I simplify it, gives me what? If I'm looking for Fk, I will say my coefficient of kinetic friction, which was given here as 0.40, or I can write 0.4, guys. Then the normal force. Obviously, the normal force in this case, since our object is on a horizontal surface, will be the mass of the crate, which is 8.5 multiplied by our gravitational acceleration. So we can find our Fk quickly there. Let me just find it. So when I put all of this on a calculator, guys, the answer I get is 33.32. okay, that is my kinetic friction. So I will substitute there. Do I know my tension? No, I do not. Do I know my kinetic friction? Yes, I do. Now is what? 33.32 is equal to, do I know the mass? Remember, the mass of the crate is what? 8.5, all this multiplied by A. So this will be my equation 1. And then for equation 2, I'm now looking at what? I'm looking at my hanger. So I'm just gonna write here hanger. This is the second part. For hanger, guys, I still have two forces there, but this one, guys, remember my object is moving. Let me just go to the diagram. We are assuming that our object is moving this way, and this direction is the right? And if our direction to the right is positive, it means that when this one moves this way, because remember, with our tension, this object is being pulled by this one, and this one is being pulled by this one. So if this one is pulling this one, that means this one should be moving this way. And if this one is pulling this one should be moving that way, okay, in terms of our tension. And then that means if this one is moving this way, this one should go that way, and it goes in the opposite direction. So this direction then means the tension here will be negative. This one, since is moving in the direction of motion, will be positive, our Fg. And then when we now substitute into our equation, I think I should write here because there is enough space. We will say that we have Fg minus T, which is equal to 0, or rather, no, not 0, my bad, it should be Ma. Okay, and then when we substitute, what is Fg? Remember, Fg is supposed to be mg minus T, which we do not know, is equal to Ma. Ma is the mass of the hanger, and in this case, guys, the mass of the hanger we will work with is this one. This one is the mass of the hanger when our object is moving. Okay, that's why we are looking for acceleration. So this means that our mass here is going to be 7.4 multiplied by A. Yeah, and then here we are going to again have 7.4 multiplied by 9.8 is equal to 7.4A. So this will be our second equation basically, right? After here, guys, what do you think we should do? After here, okay, there's something I missed. Please excuse me. I forgot to put our tension. So we will have this minus T, which will be equal to 7.4A. Then from there, we are gonna solve for something. What are we solving for? We are solving for acceleration. So now that I have two equations, remember this is my first equation. The second equation, let me simplify this first. If I simplify this, it means I'm saying 7.4 times 9.8 And guys, when I say 7,4 times 9,8, the value I get is 72,52 minus t is equal to 7,4a. Okay, and then from here, what I'm going to do is solve for a. How do I solve for a? On equation 1, guys, what I'm going to do is write transpose everything to the other side. Let me take this one and put it on the other side. So that means I can solve this equation further and say t is equal to 8,5a plus 33,32. Okay, this will still be my equation 1, and then I'll take this equation 1 and substitute it here. Okay, all right, after guys I've done this, I'm gonna take this and put it here. Okay, where I see t, I'm going to substitute with this part. Okay, the one I've highlighted there. So this means that I'm going to have 72,52 minus, in brackets I'm gonna have 8,5a plus 33,32 is equal to 7,4a. Then if I'm removing my bracket, I'm multiplying by this negative. That means I will have 72,52 minus 8,5a minus 33,32 is equal to 7,4a. And then from here, I'm adding my like terms. Okay, this one will subtract from that one, and then this one I'll bring to the other side. So if this one goes to the other side, it will become positive, right? That means I will have 7,4a plus 8,5a. So what does that give? 8,5 plus 7,4 is going to be 15,9. So I will have 15,9a is equal to, and then I'll see this one minus this one. So I'm saying 72,52 minus 33,32, and the value I get there will be 39,2, and then I'll divide by 15,9 on both sides. 15,9 on both sides. So when I say 39,2 divided by 15,9, the answer I get is this. These will cancel, therefore a is equal to 2,46, or let's say 7. Yes, 2,47 meters per second squared. That's when I round off to 2 decimal places. Okay, what you'll notice, guys, here is that because I'm having a limited space when I'm answering here, I'm moving all over the place. But yeah, to make things easy for you, we'll say that this is our step 1 here, this whole part, that's our step 1. Then our step 2 will be this one here, and yeah, this one is part of this step. Remember, we have to find our kinetic friction first, so this one we also do on the side, or yeah, let's just put it that way. Then this will be our final step. I guess we'll say this is step 3 when you substitute this formula into this one. Okay, but yeah, that's how you move. You'll write firstly this part, and then go to this part, and then this part. Okay, now let's look at the last question. The last question says a 5 kg block is now placed inside the crate and the experiment is repeated. How will this affect the maximum static frictional force now experienced by the crate? Choose from increases, decreases, or remains the same. Give a reason for the answer. So guys, when you answer this question, you will look at the relationship between normal force and mass. Okay, and that relationship is directly proportional, because it means that the more mass I have, the more my normal force will be. And then we also look now at the relationship between normal force and friction, and it's also directly proportional. So what you will notice is that when I'm looking for the normal force of the crate, I obviously say normal force is equal to mg. Okay, let me start it here. Normal force is equal to FG, which is equal to mg. When my mass of the crate is initially 8,5, then I multiply by 9,8, the normal force I get is this one. So when I say 8,5 times 9,8, the normal force I'm getting is 83,3 newtons. But now they are telling me that my mass of the 8,5 will increase, because obviously once I place a 5 kg block inside my crate, it means that I'm taking the mass of the crate and adding it with the mass of the block, and that mass will be what? In this case, 8,5 plus 5 will be equal to 13,5, right? So I will have 13,5 kgs. Now let's use this mass to find the normal force. If we do that, we'll say 13 multiplied by 9,8, and when I say 13,5 times 9,8, I get a value of 132,3 newtons. And what does this mean? This means that because I've increased my mass, the normal force increases, and if the normal force increases, the static frictional force has to also increase. So the answer that I'm going to choose then is what? Is increases. Okay, the static frictional force will increase. And why does it increase? It increases because me increasing the mass increases the normal force, and the normal force is directly proportional to friction. And that's how you will basically answer this question, guys. It's worth 15 marks, and normally 15 marks says you must take 15 minutes to answer the question, but because obviously I'm trying to explain to you things slowly, I took this long. And I hope, guys, you enjoyed the video, and if you did, please give it a like, and yeah, a share if you can as well. And I want to also give an advice to a struggling student to say that if you are looking at this question, you want to know how to answer 2.1, 2.2, and maybe 2.4. Okay, that would mean you would get a minimum of how many marks here? 6 marks at least. Okay, and if you are a well-off student, obviously you should answer every question. Okay, but yeah, that's how you were supposed to approach this question, guys. I hope the video helped. I'll see you on the next one.